All right, guys, we are on Unit 3, Day 2, and this is called the exterior angle of a triangle. All right, so exterior angle is just formed by extending a line or a side of the triangle, one side. And so we have that drawn for us in the picture. In the warm-up, it says in triangle ABC below, AB is extended to point D, and it tells you that angle A is 45 and that angle C is equal to 85 degrees. And they want to know the measure of angle C to B to D. They want to know this angle here. So we have just spent a couple days on day 1 talking about that a triangle's 3 angles add up to 180 degrees. And so if we have our 180 degrees and we take away the 45-degree angle and we take away the 85-degree angle, we'll be able to figure out the third angle of the triangle, which ends up being 50. And so we can go ahead and put that 50 in our picture. And now we just have to realize that the angle we're looking for and the angle we just found form a linear pair. And that linear pairs add up to equal 180 degrees. So if I take my 180 again, and I take away the one angle of the pair, I will be left with 130 degrees for my exterior angle. Okay, and what we need to go ahead and see is an easier way of getting that 130. Instead of doing the 2 steps we did, first step we found the 50, second step we found the 130, which is our answer. We could have done this step problem in one step if we realize the theorem for the exterior angle. And that theorem is that these 2 angles who are inside the triangle, however, they are not next to the 130. The 50 is next to the 130, so the 50 would be called the adjacent angle. Therefore, these are what they call the 2 non-adjacent interior angles. If we would have just added them together, we could have got our answer of 130 in one step. All right, so we didn't even have to find the 50. We could cut out that middleman step and go right to our answer. And that's what we're going to have to do today, because today they're not going to give us angles like 45 and 85. What they're going to give us is expressions instead, and we're going to have to solve for x. And this will be the only way in order to find out what those 2 angles are. So here we go. So exterior angle of a polygon is the angle formed by extending one of the sides of the polygon. And our polygons are all going to be triangles today. Okay. The exterior angle forms a linear pair with the interior angle of the polygon, just like you saw in that warm-up, the 50 and the 130. Okay. We also get this exterior angle inequality theorem. It says that the exterior angle of a triangle is equal to the sum of the 2 non-adjacent interior angles, which if you go back to the warm-up, the non-adjacent interior angles were the 45 and the 85. Again, they're interior because they're inside the triangle, and they're not next to or non-adjacent to the exterior angle that you're looking for. The measure of an exterior angle of a triangle is going to be greater than the measure of either non-adjacent interior angle. So again, what does that mean? If you look back at the picture in the warm-up, the 130 for the exterior angle is greater than the non-adjacent interior angle of 45. And the 130 is also greater than the non-adjacent interior angle of 85. Okay? Because in order to get that 130, you have to add those 2 45 and 85 degree angles together. So it has to be greater than both than them separately. Okay? All right, let's move up. It says using the accompanied diagram, fill in the following conclusions. So in the first bullet, they want to know what 2 angles added together give you angle 4. So if I look at angle 4 and realize that he's an exterior angle, It's the two non-adjacent interior angles that would add together to equal it. So it would be angle 2 and angle 3 would add together to equal angle 4. Therefore, in the next column over, angle 4 must be greater than, that's a greater than symbol. Angle 4 has to be greater than angle 2. And in the next column, angle 4 must also be greater than angle 3. Okay. All right, in the next bullet, it's asking about which two angles add up to angle 5. So if I look for angle 5 and realize it's an exterior angle, his non-adjacent interior angles would be 1 and 3. They're inside, but they're not next to 5, so they're the non-adjacent interior angles. Those are the angles that would add together to equal angle 5. Therefore, angle 5 must be greater than angle 1, and angle 5 must be greater than angle 3. Okay. Last bullet, in order to get angle 6, who is an exterior angle, you would have to add the non-adjacent interior angles. So the interior angles that are not next to it would be 1 and 2. And so angle 1 added to angle 2 would equal angle 6. Therefore, angle 6 is going to be greater than angle 1, and angle 6 will be greater than angle 2. Okay. All right, let's try some examples. In number 1, it says in triangle OVE, OE is extended through O to L. Okay? And by the extending that side, that's how you get the exterior angle. And it says if the measure of angle E is equal to 49 degrees, and the measure of angle V is 72 degrees, find the measure of angle VOL. They want to know the exterior angle. So we could do this like we did in the warm-up, and we could find the last angle in the triangle and then do a linear pair. Or if we want an easier way, we're going to take these two non-adjacent interior angles, we're going to add them together, and it's going to equal that angle every time. And so 72 plus 49 is equal to 121 degrees, which would be our angle VOL. And that one's done. If you want to double check it to make sure it works, if you're not sure you believe it, we could find that third angle in the triangle. If we have 180 degrees and we took away the 72, we took away the 49, we would be left with 59 degrees for the last angle inside the triangle. And then we could do a linear pair. 180, take away the 59, and guess what we get? 121. So we took two steps, step 1 and step 2, and made it a little bit simpler and made it possible to answer the question in one step. So it's a good theorem. It's a nice shortcut. Mathematicians always love shortcuts. Okay. All right, so let's go ahead and take a look at number 2. Number 2 says in triangle DEF, an exterior angle at F. So in order to get an exterior angle at F, we take this bottom side, we extend it right through F. Okay? And it says that that exterior angle is 8x plus 15. If angle D is 4x plus 5, and angle E is 3x plus 20. So in this case, we can't do question 2 like we did question 1 because we wouldn't be able to figure out this last angle inside the triangle with expressions instead of numbers. So we're going to remember our theorem that it says take the two non-adjacent interior angles, add them together, and it will always equal your exterior angle. So we're going to take 4x plus 5, who's one of our non-adjacent interior angles, add our other non-adjacent interior angle, and that's going to equal the exterior angle every single time. Okay, we take our 4x and our 3x, combine them to get 7x, take our 5 plus our 20, to get plus 25. So the left side has been cleaned up by combining our like terms, and now we're going to go ahead and move our terms around. And we end up with this. One more step. We're going to subtract 15, and x comes out to equal 10. Okay? And that's actually all they wanted to know. And so we could stop there. Or if you wanted to check, we could go ahead and plug in. 4 times 10 is 40. 40 plus 5 would be a 45-degree angle for angle D. 3 times 10 is 30. 30 plus 20 is 50. And on the outside here, 8 times 10 is 80. 80 plus 15 would be 95. And so we could go ahead and now do this one like we did in the warm-up or in question number 1. And we're just going to check our math. But if we take 180 and we take away the 45 in the triangle and we take away the 50 in the triangle, we'll be left with the last angle in the triangle, which is 85. And if I put 85 here, I'm going to be able to check to see if this linear pair of 85 and 95 add up to equal 180 degrees, and it does. And so I know my answer of x equals 10 is correct. All right, I'll see you guys on the back side for the second page of day 2 notes. All right.